2. That's where the S came. Now, we're going to look at this problem, but not all S's you guys have that the infinite slope on the tangent line. This one just happened to have that, okay? But just because some S's, it's not always going to be true. 19, it's differentiable everywhere except 0. 20, it is differentiable everywhere. 20 is differentiable everywhere. 21, not differentiable. Wait, I'm sorry, it is differentiable at x equals 0. And then at 3, it's not continuous at 3, right? So if it's not continuous, it's done. You know what I'm saying? Don't even check. Like if you graph that function and something isn't continuous.
Yeah, not at 0.
At 0? Okay.
Because there's a discontinuity there.
Yeah.
It's just the function is differentiable at 0. Like at the bottom.
But the function isn't continuous at 3, right? Like the original function. Did you graph it?
Yeah. I'm saying it's not differentiable at 3. Or 0.
Well, if it's not continuous, it's not differentiable.
Right. So it's not differentiable.
Yes.
At 0 or 3.
I got 0's good. Check. Let's graph it. 22 is all good. And 23. Now, 23, did you guys use the symmetric difference quotient? Do you remember what that is from the notes? It wants you to test something. X plus h minus x minus h. Try it right now if you didn't do it already. The 1 over x function, write it out. Instead of doing, again, definition of the derivative, only doing a symmetric difference quotient for 1 over x at 0. 1 over x at x equals 0. So your quizzes are done, you guys. I'm going to get them back tomorrow. I want to get through all the notes. But a lot of you guys, I didn't take off this time, but if you don't have this on every single step in the future, I'm going to take off a lot of points. A lot of you guys went through the whole process. You did all the hard work, but didn't actually know what was going on. Because when you got to the end, you put something different. Here's symmetric difference quotient. We're going to go a little right and a little left. We're actually going to go 0.001 right and left. Okay? And x is 0. We want the x value of 0. So f of x plus h is going to be 1 over 0 plus 0.001 minus 1 over 0 minus 0.001 all over 2 times 0.001. And find out what that value is on your calculator. This is setting up a symmetric difference quotient to find out what the instantaneous rate of change is at x equals 0 for the function 1 over x. Find out what this is. From the graph, is this thing differentiable at x equals 0?
No.
Why is this function not differentiable at x equals 0? It's not continuous, you're done. But this actually has a value. Like if you do dy dx that you calculate, it's just going to leave a blank. If you do 1 over x squared, it'll give you 0. Again, just like the absolute value function. But this is in numbers. Anyone get what number this is? Calculate. Did you hit?
1,000.
Bigger than that. It's a million. Do the numbers. Like, you know, this is what this simplifies to is 1 over 0.001 minus a negative is plus. This is going to be a number because it's minus a negative. So you're going to add the same thing on both sides. So you're going to get a value. And when you simplify, you're going to get a million. Which is a value. It actually gives you a value at 0, which isn't true. Does that make sense, you guys? And this is another place where that symmetric difference quotient fails. Going a little bit to the right and a little bit to the left. Because of the symmetry of the function, it gives you an error on the differentiability at that point. Does that make sense? All right, everyone graph 18 on your calculator. The cube root of, was it 3x minus 6 plus 5?
Yeah.
Graph it on your calculator. Like I saw some people did all these on their calculator. Some people tried it by hand. But again, let's do this one on your calculator. Graph the function, and then graph the derivative. And who borrowed this one?
I didn't pick
Oh, good.
I plotted number 21 and it's got 2 possibilities.
And 0, 2.
Yeah. So it's not differentiable.
Yeah. You guys, 20, 21. 21 not differential at either one. No, this is at 0. What? Look at the functions. Just plug in 0 at each of these functions. That's continuous.
Oh, so it's right. You can take the limit from the right, but not the left.
You can take it.
That means from the left, not the right.
This is continuous. Three x minus 6, guys? Okay, if you just take a look at the graph, so it looks like it's a continuous function, it's going to be differentiable everywhere. The only possible candidate for a bad place is right where that s happens. Do you see it? Do you see it, Rafi? So, but again, not all s's are going to have that vertical tangent line. So one way you can test it is if you take the derivative of this on your calculator. How do you do that? Math 8 vars y1 comma x comma x. Turn the first function off, keep the second one on. And there it goes, and then it's shooting up. Do you see it? This thing is going to have, what it's plotting, again, is a graph of all of the slopes of the tangent lines for the original function. And at 2, it's shooting up. It's got an infinite slope at that point. Do you guys see that from the graph? So again, it's a tool you guys can use. We tell you guys all this calculator stuff in 3.2 because you can use it when you have the use of your calculator. You can do all of these things with your calculator when you have the use of it. Okay? In 3.3, these are all the skills without the calculator. These are the rules. Okay? So let's talk about those now.